using point slope form. Awesome. What I want to do in the next part of this video is we're going to go through with a different function, and instead of finding the slope of the tangent line at one point, let's find the slope of the tangent line at all points. So this is the last problem for this video. The function is the square root of 2x minus 3, and I want to find f prime. Since this doesn't say f prime at a specific point, we're going to find f prime everywhere, which means we need the limit as h approaches 0 of f of x plus h minus f of x all over h. Well, let's see. F of x plus h means we go to f, this function here, and everywhere there was an x, we replace that with x plus h. So we've got square root 2 parentheses x plus h minus 3. From that, we're going to subtract f of x, which is the square root of 2x minus 3, all over h. For those of you that have gotten really good with limits, you know what's going to happen. If you evaluate this limit at 0, you'll have square root of 2x minus 3 minus the square root of 2x minus 3. That's 0 in the numerator, 0 in the denominator. Uh-oh! We have an indeterminate form. We need some algebra trickery. What we're going to have to do, because of the square roots here, is we're going to multiply by the conjugate. So let's go through and do that. Limit h approaches 0, square root 2 parentheses x plus h minus 3 minus the square root of 2x minus 3 all over h. We're going to multiply that by the conjugate, which is all the same stuff except with a plus sign in between. 2x plus h minus 3 plus the square root of 2x minus 3. Now, rather than making the largest box we've ever done, when we multiply by the conjugate, we're doing it because when I take this term over here, the square root of 2 parentheses x plus h minus 3, and multiply it with itself, what's going to happen is we're just going to get 2 parentheses x plus h minus 3. Okay, let's keep multiplying. We take this first term times the last term over here. When we move to this last term in the first parentheses with the first term in the second, those will actually cancel each other out, and then we just have negative square root of 2x minus 3 multiplying with positive square root of 2x minus 3, which leaves us the negative of 2x minus 3. In the denominator, we still have the h, and we have square root 2x plus h minus 3 plus square root 2x minus 3. If I distribute the 2 through, we're going to have a 2x. That'll cancel off the negative 2x over here. We'll have a 2h. That does not cancel with anything in the numerator. We have a negative 3 minus a negative 3, which is going to get us to the limit as h approaches 0, 2h over h square root 2 parentheses x plus h minus 3 plus the square root of 2x minus 3. The h in the numerator and the h in the denominator are free to cancel each other out. If I just want to rewrite this, it's the limit as h approaches 0 of 2 over the square root 2 parentheses x plus h minus 3 plus the square root of 2x minus 3. Hold on, you made it through the hard part. We're almost done. Now take the limit as h approaches 0. The numerator stays 2. The denominator, 2 times x plus h is getting closer to 0. We have square root 2x minus 3. Plus, there's no h here. That's another square root of 2x minus 3. So we have 2 over 2 times the square root of 2x minus 3. If you'd like, you can reduce, and that's going to leave you with 1 over the square root of 2x minus 3. That is the derivative everywhere. Now, why do we go through the pain of finding the derivative everywhere? Because if you were asked to find f prime of 3, to find the slope of the tangent line at 3, is actually really easy. All you would do is, now that you found the derivative, everywhere you had an x, you would replace it with 3, and you get 1 over the square root of 3. Since that's a positive number, that would tell me that the function is increasing at x equals 3. If the derivative was negative, we would say that the function is decreasing at x equals 3. That's it. Those are two really hard problems. I wouldn't necessarily expect that you would have to do either of those problems in the middle of a testing situation, but I'm pretty confident that if you could solve those two problems, you have mastered finding the slope of a tangent line, and congratulations.